In the previous video, we simulated the buck boost converter and discussed its operation. The link is in the description below. In this video, we are going to charge and discharge a battery using the buck boost converter. Now, we are going to add our battery and see if this regulator is able to charge and discharge our battery. Open the library icon. Open electric drives. Under electric drives, open extra sources. Add the battery to the model. Close the library. Rotate our battery so that the signs are reversed to match the output. Because the output voltage from the regulator is reversed, connect battery's negative and positive port to the output of the resistor. The voltage source and battery source are reversed in signs. Now add a bus selector to the model. Connect the bus selector to the output of the battery. Open the properties of the bus selector. Select and remove the signal 1 and signal 2 of the output. For the signals in the bus, select the SOC. Select the voltage. And select the current. Apply and close. To measure the SOC, voltage, and current of the battery, we add bring a scope to the model. Put 3 as the number of input ports for the scope. Connect the outputs of the bus selector to the scope. Open the properties of the battery. Change the initial state of charge to 50. Change the response time to 1. Apply and close. Add the multiply block to the model. Connect the output voltage measurement and output current measurement to the input of the multiply block. This will measure the power consumed at the output by the load. Duplicate the display block, and connect the duplicated display block to the multiply block. On the new display block, change the name to power. Open the battery scope. Under the View menu, click on Layout. Select 3 box for the scope layout. Click on the Play Simulation button, and start the simulation. From the simulation you can see that the state of charge, which is the SOC, shows that the battery is charging. While the regulator is charging the battery, voltage is still being supplied to the load. We can see that the voltage charging the battery is positive and the current is negative. The battery's SOC from 50% is going upward, which indicate that the battery is charging. We can see from the display that the power supplied to the load is above 1600 watts. Open this scope. You'll see that the voltage at the load is lower than the supplied voltage, which is about -10 volts, and it is the same with the voltage charging the battery, but the current through the load is very high. So, let's reduce the amplitude of the voltage source to 5. Open voltage source properties and change amplitude to 5. Apply changes and close. Now let's open our battery scope, and simulate. From the simulation, we see that the battery is starting to discharge. So, with the voltage source very low, the battery is now supplies the load and no longer the voltage source. The voltage being discharged is about 8 volts. The current is very, very low. Now the simulation is complete. You see that the battery is discharging. The battery supplies about 8 volts to the load. The power at the load is about 200 watts and no longer 1600 watts when it was supplied by the voltage source, but 200 since it's been supplied by the battery. Open the scope, and you'll see that the voltage at the output is equal to the voltage from the battery, which is -8 volts. The current is also very low. Now let's change our amplitude back to 20 volts. Let's open our battery scope and simulate. We'll do a double simulation where we charge and discharge in one simulation. Now the battery is charging. Pause the simulation, and close the scope. Go to the voltage source properties and change the amplitude to 5. Apply the changes. Now we open battery scope. Play the simulation again, and you'll see that our battery starts to discharge slowly. This is a complete simulation. This shows that our system is working, and the converter can be applied as buck-boost converter, and can be used to charge and discharge the battery.
Thanks for watching. If you found this tutorial helpful, don't forget to like this video, share it with others who might benefit, and subscribe to the channel for more content like this. I'd love your feedback or any questions you have in the comments. Let's keep the conversation going. See you in the next video.